will come on. Yeah.
Okay, we're recording now. All right.
Myself.
Explaining the data analysis and hypothesis testing methodology of the tri-squared test. Okay, we have used 3 trichotomous categorical variables talking about flavors of ice cream to determine a given sample derived from a given population, whether or not they like chocolate, vanilla, or strawberry ice cream. Those are our trichotomous categorical variables. Our outcome variables we decided are definitively yes, no, or no opinion, or not applicable. So you either yes, like one of those 3 flavors, all right? You either do not like the flavors, or it's just not applicable to you. You can't digest the ice cream, or for whatever reasons. But it's one of those 3. Those 3 are mutually exclusive, okay? So when we begin to acquire data, and let's say we use a small sample out of a class using contingency sampling, we acquire that data, and across this, so this is the standard 3x3 tri-squared table. You may see that in some respects it resembles chi-squared. Rachel. So what we would have is columns and rows. Down the columns are our categorical variables. All right? So we have chocolate would be our A1, vanilla would be our A2, and strawberry would be our A3. Our B's are outcome variables going across the rows. Okay? Yes, no, no opinion. Now, because tri-squared is a fixed test, it's always going to have outcomes within the categorical variables and the outcome variables that are always going to look like this. If you break this out, it creates our instrument within the 9 sectors off the 3 research questions. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is a yes, no, no opinion for each categorical variable. We want to know if there's enough significant differences in these scores, however they're determined, at whatever the alpha level may be, of this fixed test to say we can reject the hypothesis. Our hypothesis may be that within this classroom, there are ice cream lovers, but there's a significant difference in how they view flavors of ice cream. Okay? Those 3 flavors being chocolate, strawberry, and vanilla.
That's correct.
So, when we got the sample data and we gave them the instrument over a set period of time, which is the inventive investigative instrument, off of whether or not they enjoy those 3 flavors in this specific period of time, we determined 6, 8, and 0 for the yeses of strawberry and vanilla. For the no's, a 0, 0, and 10. People really don't like strawberry. Okay? And lastly, not applicable. Boom, 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 boom. Now, across this given population, you would have an N-tri, which is the number of instruments that you actually gave out and assessed. You take the data from each instrument. So let's say the N here is 17. All right? You have 17 instruments. You can take there and see how many yeses I have across that particular one. That is tallied and put into that first cell. All right? Then the second cell and the third cell. So for each related question, it runs right across here. Very easy to tally. Okay? Now,
You add that up for each one of those?
Each one of your questionnaires.
Yes.
So if you were to take this 3x3 trichotomous table, standard tri-square table, tri-square test table, and you were to spread it out and break it out, you would have, come over here and show you. 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. You just got to add them up. You just got to tally them. And the outcome of this tally was these results. Does that make sense? Is anybody lost now? You got it?
But do you do it for each one, or are you adding them all together? Say if you have 17 participants.
For all 17 participants, when you tally them all together, you're going to get this.
Let's go practical. Take one question.
Okay.
You observe. You're based on observation.
Correct.
You created this observation matrix.
Correct.
And you are looking for particular effects or particular phenomena. Now, whatever you checked is what you're going to put there, whether it was yes, no, or
the tally sheet.
Yeah, right there. And then once you, then what does it do is once you compute the the data, then that's where your really techniques comes in, the research and analysis tool, which is that doesn't exist now.
Right.
That's your discovery.
So this is your qualitative data.
Yes, right.
This is the qualitative data from the instrument.
Yes.
This is the tally of the qualitative data. Okay? We've got to convert it to quantitative data to determine.
Yeah.
And that's the next set of computations we're going to talk about.
Nice.
But I want you to understand the qualitative data analysis process. Okay? So you have your research questions. All right? Your hypotheses are driven off of those. For the tri-squared test, it's either going to be, it's always two-tailed, it's either going to be a significant difference in, or there's not. There's not enough data to support that. All right? So we are trying to determine, is there a significant difference in this particular class in determining whether or not they have a preference for a particular ice cream flavor. Is there enough? Just looking generally at the data, it seems to be enough, but it's a very small class. We won't know until we actually calculate. Now, the beauty of the tri-squared test is you do not have to separately determine what the effect size is. You do not have to separately determine what the hypothesis testing parameters are, and you do not have to separately determine what the critical values are. They're all built into the test. All of them.
Makes it
The critical value.
All of it's built into the test. I'm going to show you from that research paper I gave you. Let's go to the last slide. Tri-squared, in order to get levels of significance to create the tri-squared critical value hypothesis testing table, because it's a fixed test, it's always going to have a degree and row effect, or degrees of freedom of 4. It's always going to be 4. Degrees of freedom are calculated similar to chi-square as rows minus 1 times columns minus 1. It's always going to be 4. So the text, the data is always fixed. It's not going to change. You're always going to have a 3x3 trichotomous table. You're not going to go up 4. You got to use another tool. It's always going to remain the same. Because of that, to get levels of significance, it's very easy to calculate within the parameters of a normal. Well, if it was a normal curve, it's not. It's an actual skewed curve because it's fixed. You're able to determine what the intervals are for sample sizes. All right? In an ideal tri-squared test, where all categorical variables and all outcome variables are 0 across the board. That's how you get your critical values. You start from an ideal relationship of 0 and you calculate out from there. Based upon that, the distribution, the tri-squared test distribution determines this. Intervals. This was amazing as I began to calculate it out. Your intervals are broken up into units based upon levels of significance at alpha levels ranging off of 1 percentile all the way up to an ideal percentile that exceeds 1,040 plus respondents, recipients, participants. So the increments and intervals of a small unit are 1 to 16. The one exception is if you do have an N of 1, it becomes a case study. And you have to use multiple tri-squared tests over time, which is called a baseline. You have to do that. Because an N of 1 is not going to give you all of the values that you need. 2, yes. 1, no.
Yes.
So in an N of 1, unless you're looking at a particular criterion within a particular variable, you still have to have a baseline over time. You got to get multiple instruments. That's the strength of this thing. You can't get one instrument and try and get a level of significance.
And this is why you bring
you can do it.
History.
You can do it.
Right.
You can do it. I'm not saying it's possible to do it. But your level and your criterion is going to be super high to get that level of significance.
Yes.
Now that's a very seasoned researcher. I wouldn't suggest that for anybody to do that. But we do have a parameter off the tri-squared test that has been accepted in research for baseline testing case studies. But I'm deviating now. It does exist. But so the smallest interval that you will have is between 1 and 16. The next level interval goes up to 17, 33, 34 to 40, 41 to 57, 58 to 74, and this is the small section interval within the tri-squared distribution. Then it jumps up to a middle. Middle goes 75 to 139, 140 to 204, 205 to 269. Then it jumps up to large. 270 to 526, 527 to 1783, and 1784 to 1040 plus. Because at that level, you're at 0.0001, so you're really not can get any level in terms of
explain to them significance of the number.
Okay. The interval ties into a probability in terms of your likelihood of making an alpha error, which we know is a what?
Alpha error.
Rejecting a null hypothesis when it's true.
Repeat that.
In other words, what you're doing here is typical alpha level. We typically say it's 0.5. So there's one chance out of 20 that I'm going to make a mistake and incorrectly reject the null hypothesis. That's a probability. That's what that's doing. The beauty of this is your alpha levels are merged to the size of the interval. So if I have an n of 17 like we said, my alpha level is 0.095. Always. And there's another table that has your critical value for it. If I'm between 1 and 17, boom, that's my alpha level.
Close to.
Oops, I touched that.
Close to the truth, the real, right?
Mm-hmm.
Because that's a lot of people don't understand that. The alpha level, what the alpha.
So what
means.
alpha is it's trying to give you a window of opportunity to say, I'm not falsely rejecting the null hypothesis when it can necessarily be true.
Or accepting, or
Right.
falsely accepting.
The opposite is a beta error, where it's false and you say it's true. Okay? So you're always hedging your bets that I'm not making a critical error within this. Problem is, when you're using an ideal number curve with a z-score, a z of 0, in other words, a mean of 0 and a standard deviation of 1, the likelihood of that is way across the board. You're really playing around. That's why most people use an alpha level of 0.5, especially when they're novel researchers. You're going to give yourself a lot of play in there, a whole lot of play in there. Here, because it's a statistically stringent test, your sample size and effect size has been calculated in here to give you an ideal alpha level. So whereas in other studies you have to calculate that out and try and determine that in sample size and try and figure out what matches here and does this match, oh man, I've done all this research, now this is my research design and I know what does not fit. It's not multiple groups.
I was talking to Marv about that, and he came out with I think it's Rosenthal, who using chi-square, and he doubled the tables, and each kind of comes to instead of using one table, he collapsed the two tables of chi-square, whatever outcome measure.
Almost like he was doing a meta-analysis on the test in and of itself.
Yes.
And so he was merging two of them together.
Yes, to create effect.
To get a more powerful, a more complex effect.
Novel, to bring
a more novel effect.
And they use that now. And you've been using that, but I didn't click until I started talking with the Merv. And then you explained to here the rigor, novelty has to be there. They also validity, reliability. That's why we do go to
right. Remember, you're looking for three things when you're doing your testing in your area. You're looking for objectivity. You're weeding out all researcher bias. You're looking for validity, truthfulness, and you're looking for reliability, consistency. Okay? Reliability, validity, and objectivity.
So how does that translate when you observation? You're testing whether your observation was meeting those three rules.
Right. So you're taking the bias out of yourself. That's essentially what this does.
So you're creating a process, a technique, to other people can come after you, and they adapt that as a technique which you got from the model.
Right.
And that's why that's your discovery. That's critical.
Now, if you need to go beyond this, we can go beyond this. There's two other techniques where we can actually render it on a normal curve within the tri-squared values. That's called tri-centered analysis. We can look at that. And we can also have a tri-squared test that tests the validity of the research instrument itself. So we can talk about that. But those are post hoc measures. And you have to get a level of significance here first before you can even deal with those. But those are some post hoc things that you can do that further your research and shows the strength of the study. But right now we're staying here. The main thing you need to understand from this is sample size and effect size will not affect you as long as you're staying within the parameters of the test. So if you know you have an N of 17, you know it's a small study, you know that it's a 0.99. Oops, I did it again. I do it every time. You gotta remember this thing is touch sensitive. You know it's a probability of 0.995 falsely, they're making an alpha error, which translates to an alpha level. It's the same as the probability of 0.995, and your critical value that you have to be greater in to safely reject the null hypothesis is 0.207. Now let's test this with our data. So in order to have enough evidence to reject the null hypothesis within our hypothesis we stated, which was looking at whether or not this particular classroom has a particular preference for a ice cream, chocolate, vanilla, or strawberry, is there enough significant difference in between whether they stated within their preferences yes, no, or no opinion to reject the null hypothesis that they do not have a particular preference?
Okay, frame it into what one of them is doing in terms of what they're looking for. You're looking in your study to a way to analyze.
We're gonna come back to her study. I want to show them the process first.
Okay.
Stay with me on the process.
Okay.
All right. So we said that, right?
Okay.
So we've already got sample data. Okay.
Mm-hmm.
Do you understand this point right here? So we know that our alpha level, we have an n try or n of 17. We know that. Oops, we're up a little high. I'm sorry. We're at 0.975. So we know that 0.484. Oh, a little more stringent than I thought. I'm sorry. Caught myself there. Ha-ha. This is the end of 16. That's good. We're actually 17. We're one increment higher. So our alpha level and our probability is 0.975, and our critical value is 0.484. We're at the bottom of this particular interval for this test. All right. Now we took our inventive investigative instrument earlier that we created, and we came out with data that looks like this. Not that slide. Go up a little bit higher, sir. For our yeses, 680. For our no's, 0010. For our not applicable, 5, 3, and 1. Okay? And we totaled and tallied all that together. Now, based upon that, just looking at it now, we could say, yeah, it should be a significant difference. I mean, got a pretty good, chocolate seems to be higher, so which one was the most popular in terms of flavor?
Of course, the
Vanilla, wasn't it?
Why didn't
Right,
it was?
yeah.
Yeah.
Okay. And the one that nobody really preferred at all? Strawberry. Okay. And there were some people in here most likely were lactose intolerant. They couldn't really digest this. All right, so we know that general descriptive statistics, general descriptively describing our particular data. We just tell that right off. But is there enough evidence here to safely reject that null hypothesis? We can't just do it with this. We've got to convert this quantitatively to quantitative data and determine if we've got enough evidence that's higher than 0.484
Because you don't
at an alpha level of 0.975. You got it. So what do? All right. We total these across rows. We total these across columns. All right. So this would be observed frequency data if we were in chi-squared. Okay. Here we call it qualitative data. That's what it is. It's qualitative data derived from this, But now we've got to turn it into quantitative data.
There you go.
Where Fisher, which he got from August Brevet, called expected data. So what do? We're going to tally them. We're going to add them across. We're going to add them down. The beauty of tri-square is, and this is when you know a mistake, rows should be the same when we add them across. Cross across. You should see similarities. Bam, 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 bam. When we get our quantitative data, you should see similarities across here and similarities across here. Why? You're going to add down here, add down here, add down here, add across here, add across here, add across here, and get a grand total here.
Right.
Got it? What does that look like? Let's go to the next slide. This. 14, 10, 9, 11, 11, 11, 33. That's our grand total.
Oh, okay.
Now, what do? We take rows times columns divided by columns. So how do we do that?
Wow. Now, the first time I'm understanding it.
Okay? 14 divided by 11, 33. Remember I told you it should be similar across? Similar across? Similar across. Why? Go back.
Again?
Because same. So when it comes to this, trichotomously, you should see the difference across the outcome variables and only there. Because the categories are nominal data. This is quantitative data.
Yes.
So what happens when we go through?
Outcomes.
This is what we get. 4.67, 4.67, 4.67, 3.34, 3.34, 3.34, 333. Now you have two sets of data. The qualitative data and the quantitative data. Okay? Last step. This is where tri-squared comes in. You take that outcome data, subtract it from the initial quantitative data, square it, and divide by add it. Boom, 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 boom. Our outcome is 30.048. Is that bigger than 0.484? Rejecting no hypothesis.
This goes this way. This goes this way. Okay. Did you understand it?
Yeah.
You got it?
I don't
And it's
have
pretty
time.
obvious.
You have time.
But
No,
I do.
you have to. You can go back and because this is what fails to come across when we're teaching learning. We fail to ask questions to go back and say.
And it's a really big significant difference. It should
It
be.
is big.
Very big.
It should be huge. Why? Why should it be huge? Look at that. Look at the differences there. They're huge. And it should be reflected in the stats.
And
And it is. I would be more concerned if this was like 666,884 and I'd be like, oh boy, this is going to be real tight. I don't know if I got enough evidence. But here it's obvious.
You can see.
10 is much bigger than 0. I'm not messing with strawberry. People generally didn't want to mess with it at all in this particular class. And the vast majority couldn't stand it at all. Somebody couldn't even digest it. For whatever the reason. They didn't want to deal with it. And this is reflected purely in the statistics.
So then I'm looking at that data based on what I'm observing. You're going to go there, right?
Yep.
But see, you have three different questions. One, you're dealing with the personal, you're dealing with the environmental, and the behavioral. So you want that big number for each one of them, and then you go back and do the analysis, correct?
So basically what you're going to do is you're trying to determine generally in your research study the factors that affect the classroom experiences males in this particular sixth grade of the sixth grade student based upon their perceptions. And you identify three factors. You identify them to be personal factors, behavioral factors, and environmental factors. And the students, based off your observations, so instead of chocolate, vanilla, and strawberry here, you would have your A1 would be personal, B2 would be, A2 would be behavioral, and A3 would be environmental. And then you have the same metrics.
Yes.
Was it positive, was it negative, or was it non-existent? Based upon their perceptions, which you observe to be their perceptions to be. And then based upon that, is there a significant difference? If there's no significant difference, well then there's nothing going on with that school that the persons, the young people say that is affecting them in that classroom environment.
Now then their perception.
But they're not saying anyway. They're not saying anyway. I'm observing.
Yes. Based off your observations on this particular instrument.
Okay. So how do you determine the personal? What are you looking at?
Three areas: self-esteem, self-concept, and ethics.
Determine if you're not interviewing them, though.
I'm watching them. I have these little determinants down here.
You already they'll display.
Read out the determinants. What are they for the personal factors?
Esteem, self-concept, and efficacy.
What are they for behavioral?
Verbal expression, physical expression, and no expression at all, nonverbal.
And the last one?
Gym, school, classroom, the environment where they are located in the
Bingo.
class.
Okay. Then your job is to describe the phenomenon you get. How do you determine the self-esteem? By looking. That's your test.
I've already described that in the paper. I mean, that's
I
mine.
understand, but I need to see
articulate
for someone who that I've not read your paper.
Explain it to them.
The self-esteem, what they look like? They look like they're shy.
Right.
So you need to explain it within these criterion factors. 1, 2, 3. What are the criterion factors that determine it? Well, you've broken it out right there. Boom, boom, boom. These are the criterion factors. Okay? And then based upon that, if there's an equity that you see in here, the likelihood of you rejecting the null hypothesis is lower and lower and lower. There's just not enough difference in there to correctly assume, for example, if these numbers were closer together,
Yes.
there would not be a significant statistical difference to reject a null hypothesis stating that this particular phenomenon exists or doesn't exist. You see? So the closer this data is, the more likely. Here it's pretty obvious, and that's why I use these particular numbers from the study. It's very obvious when you see there should be a significant difference in here, or something's going on with my math. But had these numbers been very, very close,
Yes.
and I run into that, but the beauty of this particular instrument is that even if there's not a significant difference, you can talk about that. Because based upon your particular observations in this environment, you identified that it led you to create the instrument, but there was not enough rich data to state that. But these criterion factors do exist. You observe them.
Right. Right.
So it'll be very interesting to see what your data outcome is based upon that. Rachel, I see you're in deep thought over there. Do you see the applicability of this to what you're doing?
I see how it could be used.
Mm-hmm.
For what I'm looking at, I probably would not use it right now.
Mm-hmm.
But I could see how in a future study I could do that.
Mm-hmm.
What I'm doing right now, since I'm just trying to initially understand the experiences of the students, because that's not currently known, what I would want to do is to understand their perceptions and what they perceive to be their experiences in their successful acquisition of Spanish. And then when I have that identified, I have factors identified that students have distinguished, you know, and it's not just, okay, well, the literature says that students identify these factors because the literature doesn't do that right now. I can go in at a later time and use those factors to be able to do that factor analysis. But
Right.
because they don't currently, or they're not currently expressed in the literature,
Right.
I would need to go in and explore to
You've
find
got
out
to
what they are.
determine
in
what
the
they
first
are.
place.
Right.
Right.
You don't know what they are concretely yet.
Exactly.
So you've got to
because
figure out what
I
they
might
are.
include
Right.
something that I think are factors, since the literature doesn't do it. If I wanted to go right out and use this, I would either have to speculate as far as what they are, do an in-depth pilot study to kind of gauge something, but rather than doing a singular pilot study to kind of get an idea, I think I would want to do a larger, more in-depth initial.
And that gives the strength of your study, because what you want, what you just said there is, I want to be valid.
Right.
Right. So, exactly. The advantage that Davida has is you already knew what these were, so it was easier for you and Harrison to determine what those factors were. You're at the incremental stage where this is really not being broached, and you can't make an assumption.
Right.
You got to go in, successfully navigate, and figure out and pull that out. And I think what would work idealistically in your situation is to do a battery based upon research, almost as if you were doing, let me turn this off because we're out of crossword now, but